On this episode of the Datsun build, you'll see me make this engine plate here and this transmission bell housing plate as a kind of a jig, and find the center. This is the mounting surface for the engine. These two ports here are exhaust. One of them goes down to a large opening, and this one goes down to a small opening. But I think we're just going to conjoin them, and I'll show you that on the engine later. But this tube is coolant from something. I know this had a pump that was driven through a shaft all the way down at the bottom. So what this, I don't know if this goes to it. I don't know anything about boats. But this passage here fills with water, and then I think that would go into the engine. And this is a gasket here. So it fills this entire side. And my theory is it pushes it through the engine and then must dump it out here. And it returns there or something, I don't know. And there's a hole there too though. So, let's see. It's okay, and it's a crossover. So this whole area just fills with water, and it looks like there's two drains there, one on each side, and this. So whatever this is, it's full of dirt. I don't know if that's maybe it's a clogged up passage. I don't know. Wait, looks like it gets coolant, potentially. I don't know what these are. I'm gonna push this engine over to the crane in front of the F100 and take it off the stand, and I think I'm gonna put it on a car dolly laying this side down so that we can get access to the back here, because right now we can't get access because it's bolted. So I'm gonna move it real quick. This is my designated workspace next to a bale of chicken hay in a puddle. Check that out. That is inside the block. Each one of those round humps is a cylinder. So that's one water port. Let's see, is this a port? No, this is just a channel. So that might not even need to be needed. This is a port here. That goes in next to head or something. That's a port. Water port. This is the exhaust. So you have two chambers, one chamber. What the difference is, I don't know. We're gonna mix them. Then we have this port here. So we've got two ports here, these two, these, and then this big one, and then these. Wait. Nope. Nothing there. So one big one, two, two. Just found these top ones also. Here I'm using a old box from a flywheel, putting it on the engine to use it as a template. I aligned it with some of the holes and used a screwdriver to punch holes through, and then eventually put bolts that were the same diameter as the block, the hole in the block. And then I used a box cutter, cut around it just to make it the exact same size as the engine. After getting the cardboard cut, I used a hammer and a 2x4 to tap the cardboard to put indent in the cardboard from the engine, so I would know where to cut, where the gasket would be, or where the new coolant passages that I have to build will be located at. Using a razor blade, I just cut out the cardboard everywhere that the indent from the hammer was, and the circles for the coolant ports that I'm going to weld onto the plate to attach AN lines. So this is the back of it on the engine. I'll take it off in a second, but I put the holes. There's one hole here across from here with that bolt that broke off in there. So this is a coolant port here. What we're gonna do is weld a 90-degree fitting here that has an 6, or maybe this will be like a, we'll figure it out, 8 AN or bigger. Line here, that'll be a coolant port. A line here, that'll be a coolant port, all 90 degrees. So these tubes here will come out, and then these two will have tubes that come out. So they'll be like bungs welded there, and then you screw on. And we do have those 2 ports up here, and I'm going to test, they might be connected to this. So I might not have to open those up. But that looks like it cools almost over the top of the exhaust. So let me unscrew this. Man, I'm trying not to record every little step because it'll be another like hour-long video. Damn, look at that. Whoa, looks cool. So, okay. So you can see the marks here. That's what we were pounding to get. That's where the block's at, so we know where we're at. So this is this port here, the coolant port to the cylinders. And this bigger one is actually these 3 ports. We're not gonna divide them. They all look like exhaust ports as far as I know. If not, we'll have to patch it and weld a piece of something. I don't know. We'll figure it out. But that's what we got for starters. We gotta transfer this to a piece of steel. I think I'm gonna do the trick I did last time, spray paint it. And then I left this big, and I'm gonna cut the chunk out. I'm going to cut smaller than this so that I can then actually fit it directly to the block in case any of these holes are ever so slightly off. We're just gonna leave extra material and work with it there. But I'm gonna take a break and get some water. So here's our makeshift template. So what I'm thinking is, since a lot of this is cut out in the middle, I'm thinking of welding a spacer, like space this out evenly 1 inch, and then cutting these holes and everything, cutting all this out to where I need, and then welding material where it'll seal. I don't know, the problem with that is it leaves a lot of variables for the plate to be wavy or just inaccurate. I don't like it. I wish I would have had access or the ability to find a large enough sheet of steel. And like I said, I know you can order stuff, but I don't know, man. This is just what I'm working with. This is what I got. So like I said, I think we're gonna do that. Measure it, cut it, roll with it. So this is my current thoughts, and then that will go like that. So I actually want this one a little higher. Something like that, roughly. And then, ka-chow. So I think we're gonna tack weld this stuff in place, and maybe after we weld it, paint this cardboard. I'm trying to think, and then cut where it's painted to get left with this shape. looks like total dog crap, and I don't even think it's that flat. Plus we had a catastrophic welder failure, and we're welding on like a 50-foot extension cord, so the welder is not getting enough power. It's just none of this is right for the welding. So I think I'm going to just grind those and start cutting the plate in place. Bolted this plate down, well, not all the way down, I just used these long bolts as like guides kind of, and I pushed it up against the dampener and then used a Sharpie to mark the diameter and the, or whatever, circumference, whatever it is, the circle of it, and we're gonna cut that out there. If you can see that on camera at all, that is the circle right there. So I started to cut this hole here, and I stopped because I think that's going to be a port, like a hole, like a fitting, and then connect it to one of these to allow coolant to come in. We're going to block these off. I'm going to start sticking a hose in here and find out what's connected to what. Like, are all these connected, and if I just pour coolant into one, it comes out everywhere? Or is this center isolated? Are these isolated? Or what is what? We don't know. Voila! Wow. Sweet. This will need some trimmed up touching there, but that's fine. That's what we anticipated. So that's slightly, I mean, this stuff looks slightly off. We expected that. We did make it out of cardboard. So that one right there, we're looking at the end of the bolt. So we're gonna go up a size and drilling probably all these. This up here is close, but all of it's off. Actually, it is flipped. I wonder. It wouldn't really matter though. Who knows? But there it is. The beginnings of something. This is our transmission we picked up. It is a 4L60E out of a 1998 Chevy Silverado. Got it for $100. I'm working on trying to find the center of the bell housing to mock the engine up, and I'm gonna use this pipe I'll show you in a minute, but I gotta drill this to 5/8 inch. And I only have I wish I had a full 5/8 length drill bit, but I don't. Only thing I've got is this one step on this. So I'm hoping the pipe is 5/8 in the inside and it's just this lip, but we're gonna drill the end anyway. That's nothing. We need way more than that. Well, we'll see if this is even a good idea though. So my idea to find center, since I don't have a small block, I have a small block Chevy way over there, but it's fully installed. I was gonna use this plywood, and that will give me the bell housing bolt pattern, but I need to know not only this pattern to build a duplicate of it for a mating surface, but it also has to be centered, because if it is off even a 1/16 of an inch, the torque converter and flex plate won't mount up. And even if I get them to mount up, it could wobble any direction. So, and this has to be perfectly level with the engine, because if it's slightly off, then it'll wobble like this. So imagine if it wobbled side to side, so up and down, and like this. It'll destroy itself. So my idea is to make this inside diameter, the outside diameter of this, slide it on, and then build a jig here, welding to it, welding to that pipe, and that'll give me not only the direct center, but also the bolt pattern. So we just gotta find a 5/8 drill bit, because that's all I could get. That little bit. So I found this caliper in my house, which I knew it was there, but it's broken. So this battery is super finicky. I have to either hold it or just put it just right. This cover fell off somewhere and it's gone. This measured 0.625, which I think is 5/8. And we went and bought a DeWalt 5/8 drill bit and this 3/16 inch thick, 1 inch wide bar. And here is my idea. So first piece is going to be like this, but I'm going to drill this hole first. So if this hole is off, so let's just say for instance, even if it's like that, or these holes are above it, that's fine. This first one is to completely center this shaft with this bar that we're going to put 90 degrees, so flat, even, level. And then if we have to, we're going to build the perimeter here. So if I do that above it and then drill those holes, and then next we'll come down here like this. Our goal here is to put a bar at every location, at least these top two and across, to put this center line directly in the center. So, one second, I'll grab the bar, the tube. Here is the shaft that plugs into the back of the engine. So this shaft is a splined, 20 spline shaft that plugs into the back of the 2-stroke V8, and it supplies power to the propeller, the prop. So it spins like that. Because this engine, that's how it gets its power. It does not have a bolt pattern like a flywheel, like a regular car engine would. So, nice, hasn't moved. This should be like, I gotta be really careful so it doesn't turn off on the guy. Okay, turn this on, change it, bug on me and stuff. 0.83 is this pipe we're about to use, or 0.8, yeah, 3. This is 0.87. So that is 7 minus 3 is 4. 4/100ths of an inch narrower. So okay, the reason why that's important is because we're going to drill this 5/8. The reason why we're drilling this 5/8 is because it'll fit perfectly over the end of this shaft and help center it. We're not going to weld these bars to this. What I'm gonna do is drill that hole out and slide this shaft in it. Because then once I pull this shaft out to help center it, this shaft is the same exact diameter. And then we'll go from there. Because I haven't thought too much further, but I know that it'll center line it with this. So I am going with the flow, going as I work, and we're gonna see where that gets us. So off camera, I made these spacers, just 1 inch by 1 inch squares. This was the one you saw me make, and it ended up being, it worked for just this one bar, but I'll show you why I had to make the longer one, which the longer one ended up being a real pain in the butt, and at the end it has ever so slight play, and I don't know if it's just because it's longer, but this one seems tighter, but we'll look what we got. So this slides over first, like that, and this one doesn't have holes drilled in it yet. I think these ones, I don't think these are specific. So with this, it gets a spacer and washer. We're gonna run 2 washers on this one, just because it looks like we're at the very last thread. And then we run this other one, third one. And this one, since it's 2 pieces of metal out, it's getting 2 pieces of metal spacers. And tight. And this one I marked right. This one goes right here. We're out of washers. I'm gonna grab more washers real quick. Just hand tight. This one. Okay, so there's that. Nothing's real tight. And we're going to use more, I don't have any bars down here with me, but we're gonna connect it here, just straight across, and then here. So we'll have a frame of a small block Chevy belt housing with this shaft, which you remember is the same diameter of the important one, which I don't know where it's at. So when we stick the other shaft into the engine, boom, and then mount this and then level the shaft, it'll be perfect, up and down at least. And then we gotta figure out side to side. But this will get us in the ballpark, and then we're gonna weld all this here, except this pipe. This pipe will be removed, and we'll just be left with that hole centered with all these. It's a lot of work and it's really hot, so we just gotta build her up. This is the back of this engine. You can see the splines. Come on, focus. There we go. Splines on the inside. And yeah, that thing's pretty crusty. And you got this shaft, which plugs right in. And this here is the 7/8 side, which it's also a, this I think was meant to go down by the propeller, but it's the same spline count and diameter, so it'll fit like a spline diameter. So it'll fit in there. I'll show you. Look at that. And then kind of a view of them both. So the welder here finally broke. Let's see if I can show you enough. But I did get, that's the second tip thing I had. This is called like a tip holder. Hold on. How am I supposed to talk if that's in my mouth? Why am I always putting stuff in my mouth? I ordered this a long time ago, but inside here, these are all, I suck at filming. The threads on the inside of this are completely gone. They're not there. And it's really small and I don't have a tap to run down it. And I'm just using this normal piece here. But let's see if I can show you this again. Like, look how messed up it is. Completely just broken. But I'll flip the camera around and show you what welder I have. I have a Vulcan Omni Pro 220, and I couldn't find those tips anywhere in a Harbor Freight. This welder's from Harbor Freight. So I ordered these off eBay, and let's see, I might be able to focus now. Don't know if you can tell, but the threads are barely there and they're all square. It won't thread in at all, and that's why this one barely was threaded in. But yeah, look at that. I need a whole front assembly, like this piece, and then the cover. But I don't know where to order it. Like I said, I can't find any replacement parts, at least at my local 2 Harbor Freights that I have around Crestview. One in Fort Walton and the other is in like Milton. Neither one of them have these parts. So if anyone knows where I can find these, please let me know. mounting plate for this, I wanted to use something a little thicker to mount it to this, but what I have is this 1/4-inch plate, which I think will be strong enough because we're going to sandwich the flex plate between this 1/4-inch plate and the dampener. That's my thought. We're going to use that shaft splines and cut it and drill a hole here and weld the stub with the splines so that this plate will be sandwiched and mount to this. So it will not be using the dampener to power it, it'll be using the splines. It'll only be using the dampener to help stabilize it. I measured this and the bolt circle, so these are off. If you ever try to put a flex plate on an engine, it only goes on one way, and that's because it's balanced usually, sometimes. I don't know much about Chevys, but I know Fords are like a 28 or a 50-ounce balance with steel weight on it. Anyway, that's not the point. The point is these holes, it's not a perfect circle. The spacing between them is not right, or not the same distance between each hole here. But if I use this caliper, we're looking at, they're in the same bolt circle. So what that means is like distance from center. So if you had a 4.5-inch bolt circle, then if you had a 5-inch bolt circle, the circles would be farther out from the center point. So it looks to us like, I have to be careful because this battery falls out. We have a 3.5-inch bolt circle. So every center, from this center to this center across, 3.5 inches. This center to this center, 3.5 inches. The widest steel I can get is 4 inches. So if we cut a 4-inch circle, 3.5 is smaller than 4, but that's the centers. So if we put this on here, it will be at the very, very edge of it all. Right there, that looks pretty good. I could probably paint that and find the center. So we're gonna do that. We're gonna take this to the bench and put it on some cardboard like we did before and just spray paint. I think. Okay. This is what I'm left with. That's like the best one. And this side, everything else is kind of crap. Like it splattered through, but we can still see the Sharpie center line, so I'm gonna drill that hole there and then probably pilot hole these ones. That one there is not used. That's not a real bolt. It's just a hole. So those 6. And yeah, I know that one's like on the edge. This all could be shifted over, but I've got this 4 1/4 hole saw, and if you look here, that line is where the old crank used to be. I mean, this is almost the same exact size. So I mean, I just set it on here like this, kind of eyeballed center, and then traced around it to see where we'd be at, and we're pretty good. Like we knew that was gonna happen, knew that would happen. We could have avoided this side if instead of doing 2 inches, 2 inches, and 2 inches, I could have done 2 1/4, you know? But I didn't think that far ahead, or didn't think that much. But you can see here, I mean, it wasn't perfect circle in it. I don't think it'll matter too much. This is all prototype stuff. Building a prototype, if we run it like this, that's fine with me also. So I'm gonna put this in the drill press and we'll see if that weak press can even spin this baby. Okay, not happening. Plus look, that line is on the inside, so it's actually cutting a smaller diameter. Plus that thing, it's like, it's not doing it. So we're just gonna use this line and use the cutoff wheel, cut it as round as we can, and then grind for days. Okay, so the input shaft, drive shaft, or whatever it's called here, the thicker portion, which is also the bottom section here, measures 0.84. 0.842, which is actually spot on perfect. So 7/8, it's like 7/8 of a shaft. So we're gonna use that 7/8 step bit to drill this hole. And that should center this flywheel plate. We are now going to test how well this shaft fits in this hole. I really don't want to get metal on it. It's a greased up shaft, so when I slide it into this hole, any metal shavings might stick to it. Oh man, that is like a glove. Now I just gotta make sure that it doesn't look straight at all though. Almost looks like I drilled off to the side, which completely could have happened. Maybe I should have used the drill press at the end. Alright, I'm gonna run it through the drill press. Yeah, it looks perfect. Man, if I messed up on my only chance. Oh my word, oh my word. All right, so I measured this and it is ever so slightly not centered. I'm talking hundredths of inches, like 5/100ths of an inch. So that's less than 1/10. That's half of 1/10 of an inch, so that's probably fine. But here's this plate. And we saw a couple things, and we're just going to touch on this really briefly because the last videos about why the intake's the way it is. That's because that is the bottom of the engine. So any carburetors or anything would have been facing the bottom. For the engine to be positioned correctly, it has to be up here. And this is the front of the engine. I know some people were saying, why are you doing it at the front? This is the front. The orientation of how this engine is completely different than a regular engine. So the front, the bottom. So we thought we'd just touch on that very briefly. In the next video, you're gonna see me finish this. Having some trouble. I'm trying to just take this to a machine shop and get this centered on the harmonic balancer because I'm just doing it on my bench and drill press is just really difficult. Here's the back of the engine, that plate that I was making. We removed the harmonic balancer, and here's the transmission adapter that we have. So this center shaft, right now it's just loose. This is the direct center, and you already know this is the same diameter of this shaft, so it's gonna help us position it all where it needs to be. But right now we're stuck on me thinking that I really do need help getting this bolt pattern centered because it will, the first time the engine starts, within seconds, it'll destroy everything. Probably the crank bearings, the transmission, and it'll self-destruct itself if it's not perfect. So that's where I'm hitting a roadblock. Thanks for watching. Stay tuned next week every Tuesday around 4 p.m., whatever time zone I'm in. But thanks.